Okay, Jesse.
That's fine.
Good.
Okay, the quiz has only 10 questions. They're a bit more involved. So the first one is anyways, if anyone ever watches this video, there's the practice quizzes over there. Quiz 3.3. Number 1 says a fence needs to be built to enclose this rectangular area. If there's 10 meters of fence to use, what's the maximum area you can enclose? So this one is what we done before. So you got X, Y. And so it says you're using 10 meters of fence. So that's your constraint. Your constraint is that 2x plus y has to equal 10. Okay, so there's your constraint. So for example, if x was 3, y would have to be 4. That's just one example. In fact, 3, 4 actually seems like a pretty good answer. 3, 4 gives you 12. 12 is a pretty good area. Anyway, so the calculus of it goes, what am I maximizing? I'm maximizing the area, which is x times y. So all I got to do is substitute. I'm going to replace the y with 10 minus 2x. Distribute that x. And then, okay, that's my area function. Take the derivative, set it equal to 0, solve for x, you get 5/2 or 2.5. Let me pause there. Are there any questions on any of those, on maybe setting up the constraint, writing the area formula, doing the substitution, or taking the derivative? All pretty straightforward, right?
Mm-hmm.
So from there, the question just says, what's the area? So, okay, let's calculate the area now. You could certainly plug back into this or plug back into this. It's up to you. Let's say I plug back into this. If x is 5/2, then y would be 5, which means the area is that times that, 25/2. The answers happen to be written as decimals, I think, so that's just 12.5 square meters. Do those last 2 steps make sense? Yes?
So where did you get the 4?
The 4 is just the derivative of 2x squared is 4x. Any other questions? So, yeah, that's the answer. So, pretty close to that original answer we looked at, which was 12. But turns out you can go 12.5. You can't go any bigger than that. That's impossible. Okay, number 2.
You're good?
Bro.
That is not the edge of the table.
You all right?
Yeah.
You eat your funny bone?
No, I have my knuckles.
Oof. I'm did that on the
Knuckles.
grand
That's
tower
Sonic's
last night too.
best friend, right?
Except it wasn't even on the counter. It was on the edge where it's all like rough.
Number 2 says the sum of 2. All right, the sum of 2 positive numbers a and b is 2. So let's just translate that into math. The sum of 2 numbers a and b is 2. What's the minimum possible value of a squared plus 3b? Now, let's just clarify something off the bat. Are we solving for a? Or sorry, is the question asking us for the value of a? No. Is it asking us for the value of b? No. It's asking us for what is the minimum possible sum of a squared and 3b. So we're going to solve for a and b. We're going to figure out what those numbers are and then plug them into that form. So the quantity that we want to maximize or minimize is a squared plus 3b. It's up to you which one you want to solve for. In my opinion, it's easier to solve for b and plug in there. So my substitution gives me a squared plus 3 times b, but a b is the same as a 2 minus a. Everyone okay with that substitution? Does that make perfect sense to everyone?
Mhm.
So maybe take one more step to write it out. Don't forget, the entirety of b is being multiplied by 3. A lot of people forget to put the parentheses, and they don't have a 3a. That could lead to a mistake, so try to avoid that. Anyway, the derivative would be 2a minus 3. And then you set that equal to 0. And the a value is 3 halves. So now does that correspond to a minimum or a maximum? Well, logically, if there's only one critical value of a, it has to be the one the question's asking, or the question makes no sense. But if you wanted to check it, you could. It would be very simple to just plug in. Oh, sorry, it's 0. So a can be anything between 0 and 2, and so if you plug in, you'll find it's negative. Plugging back into the derivative, you get negative positive. So obviously q is decreasing and increasing. So anyway, now we have to actually solve for that quantity though. So if you come back and plug into this. Now, if a is 3 halves, what's b? 1 half, right? 3 halves plus 1 half makes 2. So you have that squared. Let's plug in here. So you have q min then would be 3 halves squared plus 3 times 1 half. Does that make sense? Those get plugged in there. And so you get 9 quarters plus 3 halves. That's 6 quarters, so it's 15 quarters.
So on that one, where did you get the 1/2 again for B?
So we went back to the constraint. I guess you have 2 options. You could just plug this a value in, because you have a formula for q in terms of just a.
Okay.
That's certainly viable. I just thought it made, since the constraint was such a simple equation, it made sense just to plug this a in there and get the b value from the constraint.
Okay.
So number 3 says, very similar question, just phrased a little bit different. The product of 2 positive numbers, a and b, is 2. So the product of a and b is 2. What is the minimum value? So now the quantity we want to minimize is a plus 3b. I hope it's like semi-obvious that there can't be a max really, because I could make, or sorry, did I say max? Yes. Because I could make a trillion and b 2 trillionths, right? A trillion and 2 divided by a trillion. I can make a as large as I want it to be, thus making this number as large as I want it to be. Anyway, just a side remark there. There cannot be a maximum, but anyway, there can be a minimum. So also, again, it says they're 2 positive numbers. So part of my constraint is that a and b are both positive. So substitution. I don't know. How about, I'll solve for b, I guess. A plus 3 times, now b is just a 2 over a. Everyone okay with that?
Mhm.
Also can be written as a plus 6 over a. Take the derivative, you get 1 minus 6 over a squared. Set it equal to 0. Now you can rearrange this and solve, or just look at it and go, well, 1 minus 1 makes 0. So in order for this fraction to be 1, the bottom of it has to be 6, which means that a has to be the square root of 6. Not the negative square root of 6, because a has to be positive. So That makes sense? Okay, so A is root 6. So seems like the answer is going to be either E or F. There's one of those that have root 6s in them. So if A is root 6, then I don't know. Let's plug it into this, right? Because I mean, I certainly could. If A is root 6, then B is 2 divided by root 6, and then we could sort of get the idea. So Q min is going to be root 6 plus 6 over root 6. Now, what's 6 divided by root 6?
6 root 6 over 6. Or, no, I don't know.
Yeah, 6 root 6 over 6, which is root 6. Yeah, that's true.
Okay.
I was just thinking, so root 6 is, I'm sorry, 6, the number 6 is root 6 squared. So that's another way to think about it. It's just 6, any number divided by its own square root is just the square root of that number. Like, generally speaking, like 19 divided by the square root of 19 would be the square root of 19. That's just a generally true thing about positive real numbers. So anyway, root 6 plus root 6. Banana theorem. 1 banana plus 1 banana make 2 banana. 2 banana. Don't we love banana? Hopefully we do.
I actually hate bananas.
How do you hate bananas?
Well, so, I
The
just,
smell gives
I've
me
never
sometimes.
liked them, but my mom forced me to eat them. And so my sister came in one day and she was like, Alyssa, you might like older bananas like I do. And I was like, yeah, okay. And I sort of liked it, but you know, like I still, if they get mushy in my mouth, then
Ew.
I gag. It's really gross.
Okay.
But I still eat them because they're good for me.
Potassium.
They make me not sore, but it's a struggle.
Yeah, if you hate them, I'm sure you can find another food that's healthy. Okay, number 4 says,
He just woke up.
okay, this number 4 says, the sum of a cylinder's radius and height is 12. You can draw a picture if you want. You guys know I like to draw a picture, even if it might be a little
Whoa, George.
superfluous. All right, George, focus here. Okay, so you got a radius and you got a height. Now, it says the sum of those quantities, the sum of them is 12. 12 feet. What's the maximum volume of the cylinder? So again, obviously, you can make this cylinder super skinny and tall, make it 11.9 inches tall and 0.1 inches radius, and it'd have a very small volume, or likewise, you can make it really flat like a pancake to make the volume small, but we want to make the volume big. So what's the optimum value? Yeah. So your volume formula, what's the volume of a cylinder? Pi r squared, that's the area of the base. So that's this base area. This is true of any figure like this, where any cross section is the same. So base area times the height. Okay. So the substitution is pretty straightforward. It's pi r squared times. Replace that height with 12 minus r. Are we all okay with that substitution?
Mm-hmm.
Okay, now it's in one variable. You probably want to rewrite it first. Pi r, sorry, I made a mistake. There's 12. All right, kind of mixed up in my head. 12 pi r squared minus pi r cubed. That makes sense? That distribution, okay? The derivative would be, don't be scared of this pi. It's not a variable. It's just a number.
24 pi.
Yep, 24 pi r minus
3 pi r.
3 pi r squared. Exactly. Set that equal to 0. So it's up to you. If you feel like it's easier to factor out a term, great. If you feel like it's easier to add this dude over and then divide both sides, that's great. Does anyone have a preference of which way I do it?
Just take it.
Take it over.
Take it over?
Yeah.
Okay. I'm going to take this guy over then. So 24 times pi times r equals 3 times pi times r squared. So divide both sides by pi, divide both sides by 3, and divide both sides by r. That make sense?
8 r.
So r is 8.
Yep.
Now if r is, now that what that means is this is a round robust. Yeah, the radius is 8, and according to the constraint, the height would have to just be 4. So it turns out that, and that's because the way a cylinder is. I mean, I'm sure you guys have noticed this you pour water into like a pot, for example. Being wide gives you a lot more volume than being tall. It's because r squared. Like doubling the radius quadruples your volume, whereas doubling the height only doubles your volume, right?
Yeah.
My wife was telling me that at her work, a bunch of little kindergartners just went around the building. They were looking for circles. That was like their activity. Just go walk through the building and look for circles. Yeah, they had like little clipboards. Like, oh, I found one. they would like
That's funny.
draw it, but that just means they would just draw a circle. I thought,
Maybe that's what you have your geometry students
that'd be great.
do.
I would love that.
Your geometry students should do that. You're like, go find a circle in your home and then draw it and send a picture.
Go find squares.
Yes.
Oh, the tie. Oh, there's one. There's another one. There's another one. I found a lot of them. There's some up there.
That'd be perfect.
Anyway, oh, I didn't finish the problem. Sorry.
That's a square and circles.
Whoa.
Here's a rectangle and 2
one.
circles.
Saggy.
Okay, so the question's actually asking, what is that optimum volume? So you got to plug these back into the volume formula. So the volume's going to be pi times radius squared times height. So 64 times 4 is 256. So it's 256 pi. Cool beans?
Leo. Jesse, what time does lunch start? Hold on, I can see it. Alright. Start a Zoom meeting at 12 with the UK people. I would rather not miss it for caroling. Well, we should be back by then, and lunch ends.
There's a quick sketch of the next question, guys.
Yeah, we should be back.
The question says, if you have a rectangle where the opposite vertices are at the point 4, 0, so that's fixed. Guys, that point's fixed at 4, 0, and then this point can move anywhere along the curve. So x has to be between 0 and 4. And also the y value has to be equal to the x value plus 1. So there's your constraint. Constraint. What are we trying to optimize? The area. Yeah, well, be careful because the area is this times this. So the height is obviously just the y value of that point, right?
Mm-hmm.
So the y value of the point is x plus y. But actually, what's the base of this rectangle? It's not x. This distance is x.
X minus 4.
4 minus x.
Oh, we're so close. It's close enough.
Close enough for government.
You said it so
They even give themselves a fist bump.
confident.
Yeah, we were going for it.
You know, confidence is key.
Hey, if you can go up the
Okay. Are there any questions before we move on? How we got those two values? 4 minus x, x plus 1? Yes? Okay. Just my advice on a question like this is just be careful. It's very tempting to write x times x plus 1. Like that's a very easy mistake to make. Just maybe take an extra couple seconds to really, I would recommend drawing the picture as I usually do, but anyway, let's multiply this out. So you get, you use the product rule if you really want to, but I think it's way easier to go. So 4 times x, 4 times 1, negative x times x, negative x times 1, 4 bananas minus 1 banana is 3 banana. So there you go. There's your area formula. What's the derivative of that? Set it equal to 0. Okay, great. X is 3/2. So what is the maximum possible area? Well, plug it back in. So my rectangle, it turns out 4, so 4 is 8/2 minus 3/2 is 5/2. And then 2/2 plus 3/2 is 5/2. It turns out it's a square. It's interesting. Turns out it's a square, 25/4 of area.
So the second one comes from, so the second 5/2 comes from the original, right? From the area.
Yeah, well, I'm just plugging my x value I found. I'm just plugging it into this and this. So 3/2 plus 1 gives me the height of my rectangle, 5/2. And 4 minus 3/2 gives me also 5/2 the width of the rectangle. Kind of an interesting result. Yes.
So, not related to this problem. If A is non-differentiable, what do you, if it doesn't have a 0 differentiability, what do you do? Is there just not a maximum?
Yeah. So, like, suppose that we didn't put this bound here. Suppose someone just wrote a question that said, make a rectangle that goes from, say they didn't specify this, then yeah, you would just say, well, the area can be as big as you want it to be. George, are you playing a video game? What?
I'm on the practice.
Okay. Like you're playing Snake or something. I hope you want to get caught up.
It's just x times.
Okay, number 6. This one, now there's a few of these are going to be much more straightforward. This one is very straightforward if you know the method, because this is like the one we talked about yesterday, I think, a bit. Maybe the day before. What's so funny? So that's a function. This question basically just says, can you maximize that function? Okay, so the rightmost position. So the key here is, do you understand that rightmost position just means the maximum x value for that position function? So really all you got to do, you got take the derivative. Okay, everyone understand that? Now you're gonna set that equal to 0. We gotta solve that. So in my opinion, the easiest way would just be to factor out the common factor. So they both have a 4 in them. They both have a t squared in them. What you have left is negative t plus 3. And so what that tells you is that t values of 0 and 3 are critical. Here are the critical values. And so, again, just logically, it can't be the 0 because none of the answers are 0. So, but again, if you want, you can draw a number line and you can show that that this guy goes, if you plug these back into the derivative, you get, so what that shows you is that the function went decreasing, decreasing, decreasing. So the rightmost position was happening at 3. So anyway, plug 3 back into the original formula. So you have negative, so 3 to the 4th power is 81, plus 3 to the 3rd power is 27. So basically, this is 3 27s, 4 27s, that leaves 127. So the answer's got to be, yeah, 27. Or I can multiply the numbers. Does that make sense? The last couple steps there?
Mhm.
No? Which one? The finding the 3 or plugging in?
Yeah.
So the question's saying, what is the so you got the 3 makes sense, right?
Yeah.
So I'm plugging the 3 in here. So it's negative 3 to the 4th plus 4 times 3 cubed. And I was just saying that sort of a fast way would be this number here is negative 3, like 3 to the 4th is 3 times 3 to the 3rd. So this is negative 3 27s and this is positive 4 27s. So a bit of a banana theorem. 4 bananas minus 3 bananas makes 1 banana. But there's nothing, if that's, I mean, maybe that's needlessly confusing. If you just go negative 81 plus, so 4 times 27 would be 108. And if you subtract those numbers, you get 27. Cool beans?
Mhm.
Sorry if the 4 27s minus 3 27s was confusing. Sorry, that's probably, I said it too fast. Okay, number 7. This one gives us a volume constraint and then asks us to minimize the surface area. But it's not asking for the minimum surface area. It's just asking for what does the radius have to be to minimize the surface area. Does that make sense? And there is, make sure you read this really carefully. It says, no top lid. And if you are unclear about taking your quiz tomorrow and you're unclear, does this thing have a top or not? I will definitely clarify it for you. That's not the purpose of the questions. It's just to confuse you. But okay, anyway, so there's no top lid. All right, so the volume, this is our constraint. The volume would be pi r squared times height, and that has to equal what? 10 pi. So right off the bat, we can see that the pi's would cancel out, and you'd end up with something like, h equals 10 over r squared. Does that make sense for a constraint?
Yeah.
Okay. So we're trying to minimize the surface area, so I'm going to call that S, but there's no top lid. So there's just the bottom, which is pi r squared, and there's that rectangle of area, right? The band around it, which is 2 pi r times h. Everyone's okay with that, right?
Yeah.
Huh? No. So do my substitution like always. Pi r squared plus, if I plug that in there, I get 2 pi times 10, it's 20 pi. And then I'm going to have r over r squared, so that puts, is it okay that if I skip that little step there? I can certainly show it just in case. What I sort of didn't show there was I went 2 pi r times h. My h was 10 over r squared. And so 2 pi times 10 makes 20 pi. R divided by r squared leaves a single r on the bottom. That's what I didn't show there. Okay. Okay. Are we ready to take the derivative? So you get 2 pi r minus 20 pi over r squared. Set that equal to 0. To solve this, let's do that thing that Ave did earlier where she moved it over to the other side. So 2 pi r equals 20 pi over r squared. Cancel bobancelles. Multiply both sides by r squared. Divide both sides by 2. And we get our answer, the cube root of 10. Okay? Do we have any questions on those last couple of steps?
The only question I have there is, before you took the derivative, am I going crazy or could you simplify that?
This?
Yeah.
You could write it, you can multiply this by r over r for common denominators and combine it into pi r cubed plus 20 pi over r. But then I think you're actually making it harder to take the derivative of it. Is that what you're thinking? Yeah, it's certainly possible, but I think when you're taking calculus, you love terms like this and terms like this. You want to try to avoid as much as you can things where it's like an expression divided by an expression, because then you're forced to use the quotient rule, and you just added a layer of a level of complication that makes it more challenging. So, okay, 8, 9, 10, almost done.
Woo.
Woo. Woo, indeed. Woo.
Mhm.
Ooh.
Ooh.
Ooh. Ooh, XD.
Language of gods.
XD, XD, XD.
So
All right.
excited.
Here's one I think, did we do this exact one? Not the exact number, but I can't remember. Did we do the one where the parabola went, not the parabola, well, it's half a sideways parabola, but
I don't
did we do the one in class where it went like this, or where it was doing this?
think we
I can't
did both, but
Anyway, here's the shape. We got the constraint is that y has to equal the square root of 10 minus 3x. Obviously, we're going to be doing a little bit of chain ruling here, maybe a little bit of product ruling. Trenton's favorite, right, Trenton?
Yeah.
Loves it.
I love it.
Do you have that new game on Steam, Trenton? The one where you fire it up and then you just do chain rules and product rules.
Oh, God.
$60. It's a AAA title.
Well, I have to
Plus a
say,
subscription fee, of course.
Oh,
I
yeah.
don't think we gave an adequate laugh for that. That was
Well, wow.
legitimately hilarious.
His dot.
Yeah, that
That's
was
pretty good.
really funny.
Yeah.
I'm very.
All changed.
That was hilarious. Oh my God.
That was good. I liked that. Okay, so what's the base of the rectangle? Is think about it, this point is xy, so this is just the x value of that point, right? And of course the height is the y value of that point. So the setup here is actually simpler, I think, than the line one, but the actual calculation is more difficult. So anyway, so we're maximizing the area. The area is base times height. So x times that. Now, also what makes this one a little bit easier is it's not asking for the area, it's just asking for the x value that would maximize the area, right? So all you do is find the x value that gives us a zero derivative. Product rule. A times B. So A prime times B plus B prime times A. So that's the product rule. And what did I do inside the product rule? A little bit of chain rule. I use that square root of u is u prime over 2 root u. Everyone's cool with that? Okay. Set that equal to 0. Do a little bit of algebra. So what we're going to do is probably just move this guy over. Oh, you could try plugging him in. I think it's easier to solve it, but it's me. I mean, yeah, I guess you could plug these into this area formula and guess and check it.
Wait a minute, that's not negative.
Did I? Oh, thank you.
Yeah.
Yeah, just generally on a multiple choice, yeah, you could plug those in, but I don't know, kind of defeats it. Anyway, multiply this. So multiply this guy over here, right? Technically, you're multiplying both sides of the equation by that quantity, but you get 10 minus 3x plus. And from here, it's very simple. Okay, so that's 6 halves added over. You get 9 halves. And so that tells you the answer, so 20 over 9. Or, I mean, you could have sent the 2 over with him. Maybe that would have made it easier.
Yeah,
for
that's
sure.
what I did.
Yeah. You send the 2 over with him, there'd be a 2 times the quantity of this. You'd have 20 minus 6x. Add the 6x over, have a 9x. That's it, of course, you're over. All right. Good old Alan.
Albert's wife.
No.
So
Bob and Albert
patriarchy.
are in love. What the heck?
What?
You have to take physics. Bob and Albert are in love. It's the love story of the century. And then, no. Who's the other person? Charles. Oh my gosh. And then Charles enters this crazy love story to make it a true love triangle. Yeah, exactly. And what the heck? Poor Bob.
Charles is a homewrecker.
Yeah, Charles is a homewrecker.
Oh my God, you guys. Okay.
Anyways, Bob.
This question's gonna be really easy, actually. This will be a nice little break from.
That's all I gotta say.
That last question is pretty challenging because the calculus part of the last question is challenging, and then also the algebra to solve it is not easy. This one's gonna be way easier, I promise. The profit function is 600 times the number of widgets squared minus the cube of the number of widgets. What are we trying to do? Alice wants to maximize profit. Okay, that means I'm just going to take the derivative of my profit function, set it equal to 0. This is about as simple as they get.
Yeah.
Factor out a 3w. You get this, and Alice can see as clear as day that 0 would be a critical number. 0 is that number where she makes 0 profit. So if you graph the function, I think it would look like, the whole function would look like this. So 0 gets her no profit. 400 gets her the maximum possible profit. And then beyond that, she can just lose as much money as she wants. She makes, well, that's how these things work, right? If you're producing something and and it goes, oh, you should probably build about 400 of those, and you build 4,000 of them, well, you're going to lose a lot of money. That's how these profit models tend to be built, is they take into account how much demand there is. So you don't overproduce. Okay, 400. Last one. Particle A, it's wordy. It's so wordy and self-absorbed. I would never want this problem's autograph. Wow.
There are plenty of wordy and self-absorbed people who I would take their autograph because they're bad.
But not a book, though.
No.
You wouldn't want a book's autograph.
No.
Okay, particle A and particle B. They're both moving along the x-axis. They're moving in one dimension, okay? They have 2 different position functions. Particle A has this position function, 12 plus half a t. Okay, so it looks like that. This is particle A. Okay. Particle B is a square root function multiplied by 4. Okay. This is one we went over one a lot like this in class, where, okay, initially, how far apart are they initially? The thing first starts, it's 12, right?
12.
Right, because
You know the fraction.
initially this thing's at 12, this thing's at 0, so they're initially 12 apart, but as time goes on, this guy grows faster than this, he's moving faster than this guy, so they're gonna get closer to each other, but then eventually this guy's slope gets really flat, and so they start to move apart. So anyway, the simple thing is we make a distance function, okay, or a separation function. Separation function S. The separation function is A's position minus B's position. 12 plus half a t minus 4 root t. Is everyone okay with that idea?
Mhm.
Okay, so I could graph that. I can tell you what that function would look like. It would start off at 12, it would decrease for a while, then it would increase. If I graphed separation versus time. We're looking for the minimum separation. Take the derivative, 0 plus 1/2 minus, this guy's gonna be 2 over root t. Set that equal to 0. What is t going to end up being? Let's solve it the old-fashioned way. Move him over. Solvey. Square root of t equals 4.
Yeah.
People always mess this one up. What's the answer? Is t2?
No.
No, it's 16. Okay. How far apart are they at this moment, though?
You have to plug it back into the-
Plug it back into this to get you, so the separation at time 16 would be 12 plus 8 minus 4 times 4. So 4, boring.
Boring. I think I like
I don't know why it's
boring
such a more
answers.
exciting number. 4 units. So the closest they get is apparently somewhere around here, they're only 4 units apart.
Litty bitty. I have 2 questions. First is this, for 21, I keep getting